Okay, we'll begin real quick here just with a general overview of the demo case here to the left that we're going to be using. Let's do a who is real quick so I can I'll be using the backbeat as my backnet front end to discover and communicate with the Nexus lighting controller. The demo case that I'm using over here has the Nexus backnet lighting controller, firing card with 8 relays installed. I have a 6-button smart switch at address number 1, a 6-button smart switch at address number 2, and an interior multi-sensor at address number 3, and an outdoor light sensor at address number 4. So let's get started. I'll go ahead and click on it here and look at the device list. You can do a read all for the properties. It'll give you all the information about the backnet. It's our 10,152 is our part number. You get your object identifier and any other information that you need. Just notice that your max APU link accepted is set at 480. And go ahead and click on the object list here, and we'll build an object list. I'll give it a second here to complete. So you'll see that on this particular system with devices installed, we've got 131 objects listed. We've got binary inputs, binary outputs, and analog values. The binary inputs, there's 8 binary inputs allocated for each smart switch or sensor that's installed on the controller. So we have 8 binary inputs for address 1, 8 for address 2, 3, and 4. So we have a total of 32 binary inputs for the 4 devices we have installed. And these are the momentary inputs. We also have 32 maintain binary inputs. And below that, our binary outputs are for our relays. So we have 8 binary outputs for the relays. And then our analog value objects are used for the LEDs on the wall stations. So we have 32 analog value objects for those. And each sensor will also have analog value objects, but they don't apply. They're just empty objects. So when the controller builds the object database, it allocates 8 objects for each device. That way all your numbering and everything stays the same for each device. And then at the bottom, we have some additional analog values. AVs 1000 through 1005 are for some different settings and parameters. These AVs at the bottom in the 10,000 range, these are all the parameters for the sensors, the change values and parameters on the sensors. Okay, binary inputs. There's 2 different type of binary inputs. One that operates essentially as a momentary switch, and one that operates as a maintained switch. So again, we'll go ahead and start out right up here on this switch over here. And again, it allocates 8 objects for each device. This is only a 6-button switch, so binary inputs 1 through 6 would be used, and then binary inputs 7 and 8 are just empty objects, so they wouldn't be used in this example. So if we wanted to test button number 1, it would be binary input number 1. So come over here and select binary input and object number 1, and I can read that, and it's currently a 0 value. So if I go over and push my button and come back and read that object again, you can see it's a value of 1. So 0 is off, 1 is on. So essentially, this button acts like a toggle switch. So if we read it again, now it's at a value of 0. So on, a value of 1, off, a value of 0. And the other type of binary input is the maintain binary input, and that's basically you add 1000 to the binary input object. So if we wanted button 1, it would be, for the maintain input, it would be 1001. So we can read it. It's currently at 0. So a maintain works as when I'm going to press and hold the button. So when you press and hold the button and we read the value remains a 1 as long as you're holding the button. And at the point when you release the button, the value will go back to a 0. So it's 0, and then while the button is being pressed and maintained, it will read a value of 1 until the button is released, and then it goes back to a value of 0. So if we wanted to test the next station, button 1, this would be binary input number 9, because we have 8 allocated binary inputs for the first switch, and then the very next one would be binary input number 9. So we can read this one. It's at a 1, I push it again, it's at a 0. And then again, if we wanted to check the maintain operation of that input, add 1000 to it. So we read it, it's currently at 0. I press and hold, and it remains a value of 1 until the button is released, and goes back to a 0. Now for the sensors, I'll use the outdoor sensor here as a quick example. There's multiple binary inputs on the sensors. We'll focus on the maintain here real quick. So I'm on address number 4. So binary inputs start at binary input 25 through 32. I'm going to pick button number 3 essentially for the sensor, which would be number 27. So 25 is 1, 26 is number 2, and 27 is number 3. So currently is a 0 value. If I cover the sensor, it goes to a value of 1, and it will hold that value while it's dark until you meet your light threshold, and then the value will go back to 0. There's multiple thresholds and set points for each sensor. You can refer to the manual for the different types of operation depending on what you want to use for your situation. Okay, we're going to go over the binary outputs. These are for the relays to turn the relays on and off. So we have binary outputs 1 through 8. So we'll select our object type. We have binary output. Start with binary output 1, which is relay 1. Go ahead and read it. It's currently 0. So 0 for off and a 1 for on. I can turn on relay number 1. So there it shows currently on, value of 1. And then if I go ahead and just turn that relay off, and read again, our value shows a 0 for off. We can go ahead and write to that value. It's currently a 0, so if we were to write a 1 to relay 1, it turns on. If we write a 0, it turns off. And again, we can do that kind of throughout. If we want to turn on all 8 relays and start at 1 and go to binary output number 2 and turn that on, and 3, and so on. And the same thing if we want to turn those off. And if we're have one of these on, so what happens, let me clear this out. So if we have, okay, we'll start here with relay number 4. So if relay number 4 is on, let me make this priority. There's manual overrides for all the relays. If you manually override the relay, once you manually override the relay, it locks out so that you no longer have control over it. This is a safety feature that if somebody's working in the panel, like electrician or such, that when they override it manually, it locks out, so you no longer have control through the backnet interface. So if once they do that, the electrician, when they're done working on the panel, they need to clear. They can just hold the clear button and it will relinquish control back to the backnet interface and go to the previous state that it was in before it was manually overridden. All of the objects on the Nexus controller are written at a priority level of 16. So once you write at a priority level higher than that, it locks out local control. So here I wrote at a priority level 1. I no longer have control of relays 1, 2, and 3. So to do that, I need to relinquish control back to that priority level 16 so that I can gain access again. I'll do that with each one of those because it was still holding a priority level of 1. So now I have local control of those relays again. And that's the binary outputs. Okay, next we're going to cover analog value objects, objects 1 through 32, AVs 1 through AV 32, and these correspond to the LEDs on the stations, the various LED modes. So if there's programming on the controller for local programming, the pilots are controlled via the controller and they just correspond to the output that they're set up to control. When there's local programming, the controller writes all the AVs at priority level 16 on here. If there's no programming, then you don't have to write at a higher priority level of 16. So if there's no programming for the station, you can write at a priority level 16 and it will stay. If there's programming on the station and you write to the AV and change the color of the LED, the controller will change it back to whatever color that it's set for. So we'll start over here on station number 2. So we'll pick our analog value. We'll do button 1, so that would be analog value number 9. They're full color LEDs, so you can pick any one of 7 colors: red, green, blue, yellow, purple, cyan, or white. And there's 7 different flash patterns as well. So I'll just start with a basic one here. I'll go ahead and write that's red flash, and I wrote that at no priority level. So currently you can see that the LED is red and flashing. Now if I go to the controller and I set up, see, button number 1 to control relay number 1, as soon as I do that, you'll see that it went out, and that's because the controller is now writing at a priority level 16 and relay number 1 is off. So now the pilot responds to relay number 1. So if I want to change that pilot light, now I need to write at a higher priority level than 16. So if I want to switch it back to red flashing, I can write to it and it will go back to red flashing. And if I relinquish that control back to the controller, it will go back to the solid blue color that it was previously as told by the controller. Once you write to an LED or pilot, to turn the pilot off, a value of 0 is black or off. So if we write a value of 0, then it will turn the pilot off. You can see that the pilot turned off. And if we relinquish control back to the controller, this should turn it back on because it's programmed to correspond with relay number 1. So if we turn it off and relinquish default, or relinquish back to the controller, you can see that the pilot light did turn back on. So there's a table in the back of the Nexus system manual that lists all the various values for the different colors and different flash patterns that you can assign to the different LEDs. And like I said, you can choose anywhere between 7 different colors or flash patterns for the LEDs. And to turn them off, just again is a value of 0. Just write the 0 to your AV. Turns them off. And then AVs for the sensors are just empty objects because there's no pilot lights for the indoor sensor or the outdoor sensor. Okay, next we're going to talk about the analog value object AV1000. This is used for infinite subscriptions. So if you want to subscribe to an object and have it not expire, you can turn this feature on. So let's go here and select our analog value. And it's AV1000 to the present value property. We can read it. And to turn this on, it's a value of 1, and to turn off, it's a value of 0. So let's go ahead and let's turn it on. Okay, now what this allows us to do is we can subscribe to one of our objects. We'll just do a binary input. Let's do object 10. So that'll be button number 2 on station number 2. So, and we'll put a value of 10 seconds. So we'll subscribe to there. We can go to our COV notifications and we can see that I got 5 seconds remaining, 4 seconds as I'm pushing the button, and then the COV times out. So with the infinite COVs enabled, what it allows you to do is you can write a value of 0 seconds to the lifetime property, and when you subscribe to that binary input, then clear this. So now it will just infinitely subscribe, so the time never times out. And if you want to get rid of that COV subscription, all you have to do is resubscribe with an actual value for your lifetime. And once you do, then it will go until it times out, and it's timed out. So AV1000 is used to allow infinite COV subscriptions. So it's currently turned on, so we can go ahead and turn it back off. Then in the off position, it won't allow you to subscribe. It just gives you a service request denied. Okay, next we're going to be taking a look at AV1001, the analog value object. This is the input change buffer for all the button presses. So it allows you to monitor one analog value object and see all the button presses from the switches and the simulated button presses from the sensors. So we'll select our object type here, and we'll do AV1001 and read it here. Okay, it should be all zeros. Now, basically what this does, I'll go ahead and start here with button number 1. So I'll press and hold it and we'll get right there is button 1, press, and then it's a 0, and then when you get a release, you'll get a 1000 number added to it. So button 2, press, will give you a 2, and then a 1002. So I press and release. So now when I read the buffer, first time I read it will be a 2 showing the button press, and then the 1002 showing the button release. So this buffer just stores all the button presses until you read them. So you can be actively reading all of them to see all your button presses. So essentially if I press button 1, 2, 3, and if we read it, we'll see there's button number 9, which is button 1. We'll see the release 1009, and we'll see 10, 1010, 11, and 1011. So the same goes for the sensors. So if I cover it up, we'll see there's the button 25 press, and then the release 1026, which is the threshold above on button 4. So then when I release it, then we'll get the additional button maintains from the sensor. And you can read in the manual more on the sensor operation on how the button presses work and which ones you'll want to watch for motion and light sensing. So that's pretty much the gist of it. You're just button presses will be the single binary input, and the releases will be plus 1000. So there will be a 1 and a 1001 for the release. So 1, 1001. And the additional number 20 there was just, I probably set off motion or one of the light thresholds when I was reaching up over the sensor. And that's the analog value object 1001. Okay, next we're going to look at analog value object 1002, and this is the relay override status. So I'll go ahead and go up here and change this to 1002. We can go and read that. Currently there's no relays in an override status. So if I manually override one of the relays, then analog value object 1002, it will show the last relay that was overridden, and it will hold that present value until it's been cleared out by the clear button here, clearing the manual override, and then this will go back to 0. So if we read or manually override multiple ones, there's 1 override relay number 3, then it shows 3 as the last overridden relay. Do another one, and it show 8. Now 8 is the last overridden relay, and it will remain an 8 until those have been cleared out. So if I press and hold the clear button until it clears them out, and then this value goes back to 0. And so that just allows you to monitor if any of your relays have been manually overridden. Okay, next we're going to take a look at analog value object 1003. And what this object does is it just allows you to change the device instance. Now you can still go to the device and device instance property and change that, but we ran into some customers that didn't have the ability to change the device instance an easy way in their front end. So we created this analog value object 1003 to be able to set your device instance. So currently, you can see down here, we're running at 68,003 for our device instance. So if we read it, that shows our current value. So if we wanted to change that, I'll take it up to 68,004. Go ahead and write it to, now I've lost communication to it. So now that I've changed the device instance, I can go back here and do a who is, and we'll rediscover the controller at the new device instance. So 68,003 should show up as not available anymore. Okay, and then wait for, let me try again here real quick. I'm not sure it had time to reboot. Okay, and then here's our new device instance, now at 68,004. So analog value object 1003 is just a quick and easy way to change your device instance if you'd like to. Okay, next we're going to take a look at analog value object 1004, and this is the input emulation. Basically what this analog value object does is allows you, if you have any programming on your buttons, like essentially here button 1 turns off relay number 1, is it allows you to, let me go ahead and connect here to object 1004. So button number 1 currently turns on and off relay number 1. So input emulation just emulates a button press. It allows you to remotely push the button, essentially. So we can put our value in here and write our 1. So it works just like I pushed button number 1. If I push it again, and it cycles on and off. Same for button number 3. And turn on button number 4. And button number 5. And then my button number 6 is currently programmed as like an all off. So if I hit number 6, it'll turn all those off. So it's just remote button presses is essentially what the input emulation is for object 1004. Okay, the next object we're going to talk about is the analog value object 1005. And this is our scene trigger object. And this is essentially, it's just like the 1004 object, but the scene trigger object 1005, what this allows us to do is currently we have basically essentially 4 stations here connected to our system. So if this is a small system, this was all we were going to ever do. The scene trigger object allows you to use those remaining objects. So we have the 8 objects per station, and it stops it. So we have our objects 1 through 32. So essentially station number 5 starts at binary input 33. So we have 33 through 128 not being used on this system. So what we can do is I can start here at 33. So this would essentially be, if we had a 5th station, that would be button number 1 on that station. So I can come up here and I can program for, we'll do station number 5, button number 1, and I want it to cycle relay number 1. We'll do relay number 3 and relay number 6. So now I've programmed button number 1 for station 5 for kind of scene control. I want it to control relays 1, 3, and 5. So when I come back over here and I write that button press to there, it switches on relays 1, 3, and 5. Another press cycles them off. I set them for a cycle, essentially. Now the other, we could program them also for, let's see, we'll do like relay number 2. You can program like a maintain, normally open if you wanted to. So for that, what we would have to do is we would write the button press, and that would maintain relay number 2 on until I send the button release. So when I send the button release, my maintain that I programmed just turned off. And then I can cycle the other relays by just sending a button press of 33. Now, also, if I do this, it's going to turn my maintain relay number 2 back on. And then I'll have to send my button release to turn that one off. So obviously I've kind of got overlapping programming there, so you wouldn't want to do that in a normal scenario. But yeah, it essentially just allows all those remaining objects. You can create different scene control of controlling all your lights to use those remaining unused objects if you want to. And those can be controlled through the analog value object 1005, which is our scene triggers. Okay, last we're going to talk about the analog value objects for the sensor parameters. And let me bring my document up here. But essentially, what we have here is there's 10 parameters per sensor. So we have our AV1, and then we have the pound sign. And what the pound is, that's the address for each station. So in our example, we have a sensor at addresses number 3 and 4. So it would be AV1, 0, 3, 1, and 0, 4, 1. Same over here through object number 10. And this allows us to set the various parameters for these objects. And click back here on our device, and we'll scroll down. We'll see all these analog value objects. So we have address number 3, parameter number 1, and we see we have our 10 parameters for address number 3, and then we have address 4 here. We have the 10 parameters for sensor number 4. Click back on the document here. So scroll down. So here we have basically a page showing how the sensor operates. We have the 8 binary objects, which essentially act as virtual button presses when different things occur. So we have the exterior sensor, which has 4 different light levels that you can set. And basically this allows like daylight harvesting type options. So you can set one value at say 100 lux, and then the next threshold at 300, 500, 700, or 1000. And so you can create different events based on how bright it is in the area that you're controlling. For the interior sensor, when the motion sensor is enabled, there's one light threshold, and the remaining button presses are used for the motion control portion of the sensor. If you turn the motion sensing off, then the interior sensor can also operate just like the exterior sensor, where it gives you the 4 different light thresholds if you want to use it for daylight harvesting. An example would be using it in a classroom where you may set say 3 different levels. Like if you had 3 rows of light in a classroom, and when your first threshold was met, maybe you'll turn off the row of lights right next to the window. As it gets brighter in the room, you could turn off the middle row, and then once it reaches full brightness, for the room, you could turn off the last row of lights for energy savings. So our first analog value object is the light level. So we'll go ahead and look at AV1, essentially the first parameter. So we can look at that. So we'll go to analog value object 1, and then we'll look at this sensor here, address number 3, and parameter number 1. Oh, missed a digit here. Okay, I'm missing my digit here. I'm missing my 0 for my parameter. So this is parameter number 1 for sensor address number 3. So I should be able to read this. And currently the light level is 68. So if I cover this up, and my value now it's a 0, and I can let a little bit of light in. And so you'll see the value changing as the light increases. So parameter number 1 is just for reading the flux level in the room that your sensors have. Let's see, back on my document here. So the next object would be AV number 10,002 here. This is the light sensor hysteresis. You can adjust the hysteresis of the light sensor. We'll look at object number 3. This is the light sensor delay. It can be anywhere from 1 to 3,600 seconds. So basically this is when you want to send the button press or the binary object value. So if you may want to set this to maybe 10 minutes or something around that value, so that if you're using it in a classroom or a room, that if cloud cover comes over and the room gets dark, that the lights don't turn on and off too soon. So you'll want the depending on your application, for the light value to come down and be down for maybe it's only 30 seconds or a minute. So that's adjustable from 1 to 3,600 seconds. So you can set the sensor delay on that. The remaining objects here, these are for the 4 different thresholds that you can set. And object 8, this is used for the motion sensor, for the motion sensor delay. So you can set this anywhere from 1 to 120 minutes. So if it's set at 10 minutes, once it sees motion, essentially the light will remain on for 10 minutes, and anywhere in between, if motion was seen, it will reset for 10 minutes. So basically the room will have to be vacant for this setting for 10 minutes before the lights will turn off. So that's your vacancy delay. The motion sensitivity offset, this is defaulted at 25. So the lower the number, the more sensitive the motion sensor is, and the higher, the less sensitive. So if you have a sensor close to a doorway or a hallway or something, and somebody walking down the hallway sets off the motion sensor, then you can increase this number until that doesn't occur anymore. So you maybe go up 5 at a time until you achieve the setting that you like. If it's not picking up motion, if it's not sensitive enough, then just lower this value and the motion sensor will be more sensitive. And the last parameter available for the sensors is the occupancy sensor mode. So this is for the interior sensor. It doesn't apply for the outdoor sensor. So it can either be disabled, enabled, or enabled, but the motion sensor, the motion is just ignored. So I'll just do a quick example of the sensor. So if we say we look at sensor number 4 here, the most commonly used threshold we could set up on button number 3. So if we look at binary input, and this is set up as a maintain operation. So this would start at binary input number 25, so it'd be 26, 27 would be button number 3. So what we can do is go over here and we'll go to our sensor number 4, button number 3. We'll have it control relay number 8 and set it up for a maintain normally open. Now what this should do is when I cover it and it's dark, it'll turn on relay number 8, and then once it's light again, it will turn the relay off. Similar operation you can do with your interior sensor. The interior sensor with motion enabled only has the 1 threshold, so we would want to do the same operation on button number 1 for the interior sensor. So again, we have 1 through 8, 9 through 16. Button number 1 starts at 17, so it would be the maintain. For this, we can go back to address number 3, and we want button number 1, and we'll do this with relay number 7 and set this up as a maintain normally open. So this should turn on relay number 7 when it's dark, and when it's light and crosses our set threshold, turns the relay back off. So those would be the most commonly used applications for the sensor, just as a simple on-off, dusk-dawn type control, and you're able to expand on that if you'd like with the different light level thresholds. And that covers the basics of our sensors and sensor parameters. The sensor parameters are also able to be set with the IR remote. You can refer to the manual to do that. So if you're actually in the room and want to make some adjustments to the light level threshold, you can do that with the IR remote, or you can do it through the BACnet interface. Real quick, I'll just go ahead and add. I didn't show the values of the maintain inputs. Like, so when the light turns on for that binary input, you can see it's a maintain a value. It will maintain a 1 until the light threshold is crossed again. So once our light threshold is crossed again, it will go to a value of 0. And the outdoor sensor works the same way. That was object 27. I'll currently read that in as 0. If I cover it up, goes to a value of 1 and maintains that 1 until it's light again and the light threshold is crossed, and it goes back to a 0. So that would be how you would monitor those button presses or virtual button presses on the sensors.